Now, topic is revisiting irrational numbers. Irrational number. We know root 2, root 3, root 5, root 7. These are called irrational numbers. Why? Because if any prime number in the square root, then these are called square root. These are called irrational numbers. Okay. Now, question is prove that root 2 is an irrational number, or root 3 is an irrational number, root 5 is an irrational number, root 7 is an irrational number. Okay, at first prove that root 2 is an irrational number. And question is prove that root 2 is an irrational. Prove. See, let us assume that root 2 be a rational number. Root 2 be a rational number. If root 2 be a rational number, then we can write in the form p by q. Why? Rational number definition is if a number we can write in the form p by q, then it is called a rational number. Similarly, see here root 2 is a rational number, so we can write in the form p by q. And therefore, we can write in the form p by q, where q not equal 0 and p q are co-prime. Now, co-prime meaning if any two number has HCF is only 1, then both numbers are called co-prime. For example, 3 and 4 their HCF is 1, therefore 3 and 4 both are co-prime number. Okay, now root 2 equal, we can write in the form p by q. Now cross multiply it, then p equal twice root 2 q. Cross multiply p root 2 into q. Now both sides square it. P square equal twice q square. We got p square equal twice q square. See, p square is equal twice q square. If I say 36 equal 2 into 18. Can we say as 36 has one factor 2, or 36 is divisible by 2? Same meaning or not? Similarly, p square equal twice q square. That means p square has one factor 2, or p square is divisible by 2. Therefore, p square is divisible by 2. Okay, see, 36 is divisible by 2. Then 36 square root is 6. So again 6 is divisible by same number 2, but how many times? 3 times. Okay, see, p square is divisible by 2, so we can say p square root is p. So p is divisible by 2. P is divisible by 2. Okay, see, 36 is divisible by 2, but how many times? 18 times. Now 6 is divisible by 2. How many times? 3 times. 18 and 3 both are different number. Similarly, here p square is divisible by 2, but how many times? Q square time. But p is divisible by 2, but how many times? We don't know. So, right, let p equal twice m times. 3 meaning m, where m is an integer. M is an integer, any integer. Okay. Now both side whole square it, p square equal 4m square. Now see, this one give equation number 1. Now p square equal twice q square. Now p square equal 4m square. So plot p square value twice q square equal 4m square. Then next line is both side cancel. 2 how many times? 2 times. That means q square equal twice m square. Again, see the same condition. Q square equal twice m square. That means q square is divisible by 2. Therefore, q square is divisible by 2. So, q is divisible by 2. In the first step, see, we got p is divisible by 2. Now we got q is divisible by 2. Now that means p and q both are divisible by 2. So can we say p and q has one common factor, that is 2. But in the first line I wrote p and q are both are co-prime. Co-prime meaning they have only one common factor 1. But now we got common factor 2. Is it correct? False. So we will write two sentences from the question. See, therefore p and q have one common factor 2, but this contradicts meaning oppose, okay, oppose, contradicts that p and q have no common factor other than 1. P and q have no common factor other than 1. So write the next line. This contradiction has arisen that because of our incorrect assumption that root 2 is rational. Thus root 2 is irrational. Okay, root 2 is irrational number. Similarly, you can prove root 3. Instead of 2, you will write 3. Only 3. Since q square is divisible by 3, q is divisible by 3. Only since 2 as a 3. Okay. Again, you can write 5. Prove that root 5 is an irrational number. Then instead of 2, you will write 5. Other all systems are same. Okay. Now question number 2, exercise 1.3. Question number 2 is prove that 3 plus root 2 is irrational. See, in the previous question we proved root 2 is an irrational number. Instead of 2 you can write 3. Then we can say as root 3 is an irrational number. Instead of 2 you can write 5, 7, any prime number. Okay, for all question process will be same. Now question number 2, prove that 3 plus root 2 is irrational number. This one question process is totally different. Okay, see the process. Let us assume that 3 plus root 2 be a rational number. If rational number, then we can write in the form p by q. So we can write in the form p by q, where p and q are integers. Where p and q are integers. That means 3 plus root 2 equal p by q. See, p and q are integers. We know integers are rational number. Similarly, 3 is an integer. It is a rational number. But root 2 is irrational number. So all rational numbers write in one side. That means 3 transfer to right side. So root 2 equal p by q minus 3. 3 transfer to right side. Now P, Q, 3 all are integers. Integers meaning they are rational number. Now take LCM, P minus thrice Q. Now see, P, Q, 3 all are integers. Integers are rational number. We know rational number plus rational number into rational number, or rational number by rational number. Answer is always a rational number. So P, 3, Q, Q all are rational number. Their overall calculation is a rational number. Since P, Q and 3 are rational numbers, therefore P minus thrice Q by Q is a rational number. Yes, P minus thrice Q by Q is a rational number. See, I draw root 2 equal this one, so we can say left hand side and right hand side both side equal, so root 2 is rational. Root 2 is rational. Is it true? Root 2 is rational? We know, already we proved root 2 is an irrational number, but I wrote root 2 is a rational number. So, but this contradicts, oppose, okay? Contradicts that root 2 is not a rational. Thus, we conclude that if root 2 is not a rational, then the whole answer is not a rational. The sum of rational and irrational is always irrational. Thus, 3 plus root 2 is irrational number. Okay, if only root 2, root 3, root 5 given, then its proof process is different. Okay, again, if sum of two numbers given, then process will be like this. Okay, now here in exercise 1.3 many questions given, 3, 1 by root 2, and next question is 7 root 5. Okay, but apply this one process. Okay, and then question number 2, see the process. 3 Roman number 2. 3 Roman number 2. 3 Roman number 2 is 7 root 5. Then you will write as 7 root 5 equal P by Q. Then root 5 equal P by 7Q. See, P, Q, 7 all are rational numbers. Therefore, their calculation is a rational number. Therefore, we will write root 5 is a rational number. But this contradicts that root 5 is not a rational. Thus, we conclude that 7 root 5 is not a rational number. So, question number 3, all questions are same. Okay.